Okay, this is we started now. Uh, uh, so okay, okay, here. طيب, we have three past papers to solve. Depending on how long they take me, I might solve two book exercises that also seem like they may come in the written. But it's generally the same concept. All three past papers are almost the same thing. Uh, yeah, let's start. This is the first one I'm solving. Let me just copy this and I'll put it in the text at the bottom here. Where is it? Where is it? How did this? Hold on. Let me just delete this. Text, text here. I'll put this. Okay, so this is the first question. We start. I don't think anybody's typing in the chat. Yeah. Let me just open board. Let me see. Open board. So, they're all pretty much the same thing. You need to know how to draw an FBD for all questions, guys. Regardless of written or computer, you must know how to draw an FBD. So, here we have a particle of mass 0.3 kilograms being held at rest by two light inextensible strings. One string is attached. I'm going to underline this here. One string is attached at an angle of 60 degrees to a horizontal ceiling. So, obviously, this one here. And the other string is attached at an angle alpha to a vertical wall. See the diagram. The tension in the string, in the tension in the string attached to the ceiling is 4 newtons. Find the tension in the string which is attached to the wall and find the value of alpha. So for this one here, we're gonna draw first the FBD. Okay. So to draw the FBD, I'm gonna write down steps. Draw FBD. You know what? I'm gonna use Microsoft Edge because I can scroll down in the file. Just 1 second. So just give me a second. Okay. Yeah. So I like Edge better because just for files because you can erase easier and basically you can scroll down with the file and it won't erase. So أول شيء for step 1 we're gonna say draw the FBD. So for our particle here, we're gonna put it as a dot. We're gonna start with our y-axis and then our x-axis. Okay. I'm gonna start أول شيء with the particle. I'm gonna draw its weight, right? It's not on any incline, so we're gonna draw the weight like this. طيب. We now have two tensions because it's two strings. Let's call it tension 1 and tension 2. Okay, let's start with tension 1. it's angled up to the left, right? So we're gonna draw it like this. We're gonna call it like this, T1. We know that T1 is 4 newtons. So you know what? I'm gonna erase this T1, and I'm gonna put it a bit to the side, like this. Okay. You need to know how much is this angle here. Some people are gonna put 60. Why isn't it 60? So look here. Extend the vertical like this. This is obviously right angled here. So if this is 60, then how much is this one gonna be here? 30, right? 60, 30. It has to add up to 90. So it means this angle here is 30 degrees. Okay. How about T2? Let's see T2. T2 is angled as well, right? It's also angled. So let's draw here. We're going to draw T2, right? And we're trying to find the value of it. And we're also trying to find the angle. Some people here are going to write down the angle here and use this one here. But honestly, I'm going to use this one here because for FBDs where they're angled, and where I got used to using the angle with the vertical. Why am I using this? Because obviously this one here will be equal to alpha. Why? Here we have two transversals that are parallel to each other. You guys know that alternate interior angles are congruent. Okay, so this one here is equal to this one. Other people, what they would do is they would use this angle over here and they put it as 90 minus alpha. That's too much work. I don't want to put 90 minus alpha. So instead, I'm just going to use this angle down here as alpha. Okay, so alpha here, that means this one also here is alpha. Okay, so I now have the two forces. Some people might say, okay, so why didn't you draw your normal force? Man, it's not attached to any surface. It's just attached to strings. Usually when it's attached to strings, there's no normal force. So we now drew our FBD. So this is the first step. Draw your FBD. Okay. Are we done with FBD? No. Why? Because you have to resolve your forces into X and Y components. So we're going to resolve it into T1X and T1Y. And this one, T2, I'm going to resolve it into T2X. And down here, I'm going to put another small arrow, call it T2Y. So put the vector symbols just to be safe. Now I'm actually done my FBD. I have all my vertical forces. I have all my horizontal forces. I can start now with the second step is check your forces. Let's see. Sigma Fx. What's it going to be equal to? Is it MA or X? No. It's not going to be MA. It's going to be equal to 0. Why is sigma Fx going to be equal to 0? Because it's being held at rest. It's not moving. What are my horizontal forces? I have two horizontal forces here. I have T2X and T1X. Okay? So, when we say something's equal to 0, that means the stuff on one side is equal to the stuff on the other side. So, we're going to say T1X is equal to T2X. Which implies, what is T1X equal to? It's T1 cosine 30. Why cosine 30? So it's equal to T1 sine 30. My bad. Why sine 30? Because I'm using the angle with the vertical. صح? So T1 sine 30 is equal to T2X. T2X is equal to T2 sine alpha. صح? Because the angle again is with the vertical. So we're using sine for the X and cosine for the Y. This is our first equation. We'll substitute later. Now, the third step. Sigma Fy is equal to also 0 because it's being at rest. The whole particle is at rest. What are my vertical forces? T1Y, T2Y, and W. When something's equal to 0, that means what's up is equal to what's down, or what's on this side is equal to the other side. What's on this side? Let's say T1Y. It's equal to everything on the other side, T2Y plus W. Okay. Before continuing, I forgot to write the vector symbols. For your sigma Fx and what it's equal to, you have to put your vector symbols. When you do it here, you don't have to keep on writing it while solving. But at the start, someone on my comments said that you have to declare your vector at the start. After that, after you declare it, you don't have to restate it. Okay? Okay. So T1y is equal to T2y plus W, right? T1y, what's it equal to? T1 cosine 30. صح? Because T1y, we have the angle with the vertical, so we're using cosine for the y and sine for the x. So for the y, we're using cosine. Is equal to T2y. So what's T2y equal to? Is equal to T2 cosine alpha. Why cosine again? Because the angle's with the vertical, right? T2 cosine alpha plus W. What's W equal to? Let's just call it mg, right? mg. Okay, we now have our two equations. We can start to substitute. Before I substitute, I want to see what did they tell us to use G as. Use G as 10. Okay, so we're gonna go down and use G as 10. Okay, let's see. For the first one, T1, they told us is 4 newtons. So we're gonna replace T1 with 4. So 4 sine 30 is equal to T2 sine alpha. So you're gonna get 4 sine 30 is equal to 2. 2 is equal to T2 sine alpha. Okay, this is, we finished substituting our first one. We don't know how much T2 is. We're actually trying to find it, right? We're trying to find it. And we're also trying to find alpha. This is, let's actually call this now our first equation. The second one, let's substitute. T1 is 4. So 4 cosine 30 is equal to T2 cosine alpha plus mg. What's the mass? 0.3. So 0.3 times g, which is 10. So you're going to get 4 cosine 30. Let's actually solve this. How much is 4 cosine 30? Let me take out the calculator. 4 cosine 30. Remember, it should be degrees, yeah? You're going to get 3.4. How much was that? 3.46. Let's say 3.46 is equal to T2 cosine alpha plus 0.3 times 10 is 3. So we can take we can take 3 to the other side, and you're going to get the T2. Let me scroll down. T2 cosine alpha is equal to 3.46 minus 3, which is 0.46. طيب. This is our second equation. So T2 sine alpha is equal to 2. T2 cosine alpha is equal to 0.46. Let's find an expression for T2. Here, if I divide by sine alpha on both sides, I can get that T2 is equal to 2 over sine alpha. Actually, what? No. I don't want to use it like this. I want to keep... Ugh. 1 second, 1 second. Yeah, so I was saying... صح? Okay, T2 cosine alpha is equal to 0.46. Find an expression for T2. I'm gonna use this one. I want to keep cosine in my denominator. It's always better to keep cosine down. T2 is gonna be equal to 0.46 over cosine alpha. So here, instead of T2, what can I put? I can put 0.46 over cosine alpha. Okay, so this is, we got this. I should have, let me move this. I'm gonna move this over here. So you're gonna get 0.46 over cosine alpha is equal to T2, because I just divided by cosine alpha on both sides. Okay, Let me erase this here. Okay. So here instead of T2, what am I going to substitute? 0.46 over cosine alpha. So 2 is equal to 0.46 over cosine alpha times sine alpha. You guys know sine alpha over cosine alpha. What is it? It's tan alpha. So 2 is equal to 0.46 tan alpha. So what do you get? Tan alpha is going to be equal to 2 divided by 0.46. So alpha is going to be equal to shift tan 2 over 0.46. If you do this on your calculator, you should get 70 something. Shift tan 2 over 0.46. You get 77 degrees. So alpha is equal to 77 degrees. Guys, obviously don't skip lines in your work, huh? Try and use as much space as you can. So all of this I should have wrote it here so I can have more space. But anyway, so you get alpha equals 77 degrees, okay? So here, can I find T2? Yes, we said T2 is 0.46 over cosine alpha. So you can just substitute 77 here. You're going to get T2 is equal to 0.46 over cosine 77. So you're going to get T2 is equal to, let me see, 0.46 divided by cosine answer, 2.05. 2.05 newtons. Let's check these two answers. 2.05 newtons and 77 degrees. Let's see. This is not the mic. What was this? No. Is this the same thing? Okay, this is what I want. Okay, let me see. Question 3. They got alpha is equal to 76.9 and tension is equal to 2.05. How do they get 76.9? Huh. I think because they used non-exact answers. So over here, I think for my 3.46, for cosine 30, I think I wasn't supposed to keep it as 3.46. Let me see, for cosine 30, I should have kept it, I think, as 2 root 3. I think I should have kept it as 2 root 3. So if I did 2 root 3 minus 3, okay, I'd get this. Okay, so 2 divided by this. And then shift tan of this. Yeah, okay. So yeah, you should keep, if you have, during your working, if you get like, for example, here, for cosine 30, I got 2 root 3, keep it as 2 root 3, okay, in your working, okay? Keep it like that. And then continue solving as 2 root 3, because if I use 2 root 3, I would get 76.9, okay? Please don't mistake this. Okay, let me check the chat. Is it enough to do only grid from course revision? No. Yo, bro, can you do closet approach question? No, you can. I already did it, man, many times. Just watch the course revision. I wanna. Okay, I like edging better too. Okay, can you touch me in URM? Will the written be the exact same questions as the past paper, just with different numbers? Yes, yes, secret, yes. How do you not get bored doing this? I don't know. Why is it T2 sine, not cosine? What? Here? Because the angle is with the vertical. I used alpha with the vertical. So the x component will be sine and the y component will be cosine. What's the difference between alpha and theta? They're the same thing, Adi. Is this past papers? Yes. I just remember that we have insha. Answer key says alpha equals 76.9. I know, I got alpha equals 76.9. Here, hold on, bro. It's right here. I just explained that. I think this person's delayed. I think she's delayed. 76.9. You get the same answer, by the way. Can you please zoom out a bit so I take a pic? Okay, yes, no problem. Uh, so all three past papers together are the same question, by the way. All three questions together are almost the same thing. So okay, I think you screenshot it. خلاص. Leave site. Okay. Um, let me go back. I'm done from this one. Let me close this. I want to go. Is VCM coming? Yes. You should know it. Okay. 2020 question 3. Okay. November. Question 3. Let me download this. Uh, so, question 3 again, very similar to the question we just did, guys. Okay. So I'll try and save as much space as I can, but more than likely tomorrow it's gonna be what am I looking at? Yeah, it's gonna be like a 5-mark question. Let me open the marking scheme for this. Okay. Okay. Question 3. So what's the answer I'm trying to get? M is equal to 2.7. Okay, that's the answer we want. Let's see. And what's T? T is equal to 14.1. Okay, let's see. A block of mass m kg is held in equilibrium below a horizontal ceiling by two strings, as shown in the diagram. One of the strings is inclined at 45 degrees and the tension in the string is T. The other string is inclined at 60 degrees and the tension in the string is 20. Find T and find M, the mass. Okay, this is pretty straightforward. I'm going to do step 1 is draw the FBD. How am I going to draw it? I'm going to start with drawing my y-axis and label it, and draw my x-axis and label it as well. Let's see here. We have our particle here, right? We're going to start with its weight. I'm going to call it, let's call it mg. You know, let's not call it weight, let's call it mg. We have two tensions. We have T1 and T2. Okay, I'm going to call this here T1. I'm going to call this T2. Over here, the vector symbol, I think you should just keep it above G, not over M. Anyway, these things, the characters don't really pay attention to. But here, let's continue. T1, we have it like this. We want to know the angle it's at. See, I was solving the last question, the question we did. Oh, sorry. I forgot to. Okay, properties. Okay. Yeah, so I was solving the last question and I realized that I could just use 45 and put it over here. I can just do that. But I honestly prefer to keep it like how I'm solving every question. If you want to use 45 here, it's عادي. But I'm gonna use the angle up here. How do I know what this angle is? Let's see over here. If you draw a line here, Obviously, this is a right angle. So how much will this angle here be? 45 degrees. So here it's going to be 45 degrees. Well, I'm not saying that these two are equal, just because 90 minus 45 is equal to 45. Huh? T1. What else do we have? We have our T2 over here on the right. T2. And it's 20 newtons. Right? And let's put a vector above it. Put a vector above it. Okay. We have 60 degrees here. This one's 90. How much is this going to be? 90 minus 60. 30 degrees. Right? Okay, so we now resolved our forces. Let's now check sigma Fy and sigma Fx. Sigma Fy is going to be equal to what? Obviously, it's held in equilibrium, so 0. So what are my vertical forces? I forgot in the FBD to resolve T1 and T2 into T1x and T2x, and T1y and T2y. So here T2, I have to say T2x. And here I should have said T2y. Obviously, on your paper, it's going to look better than how I'm writing it here. But just cut me some slack, you know? T1x. T1, I'll write it here, T1y. Okay. طيب. T2, T1y, T2y, T1, T2, T1x, T2x. Okay. My vertical forces, what are they? They equal to 0. That means what's down is equal to what's up. What's up? I have T1 and T2y. So T1y plus T2y is equal to what's down? mg. Again, I should have put a vector symbol over here. Okay. Let's start to substitute a bit. T1y is equal to T1. Let's see, where's T1? It's equal to T1 cosine 45. Why cosine? Because the angle I'm using is with the vertical. T1 cosine 45 plus T2y, which is T2 cosine or sine? Cosine. Why cosine? Because the angle I'm using is with the vertical. So T2 cosine 30 is equal to mg. The mass, we don't know. It's m. G, we know it's 10, so 10 m. T1, we don't know how much it is. We're actually trying to find it. So we're going to keep it as T1 cosine 45 plus T2 cosine 30. T2, we know is 20. We're going to put it as 20 cosine 30 is equal to 10 m. Equation number 1. Second thing, sigma Fx is equal to what? 0. What are my horizontal forces? T1x and T2x. That's it. So that means since they're equal to 0, it means what's on the left is equal to what's on the right. Always. T1x is equal to T2x. What's T1x? T1x is equal to T sine, sorry, T1. T1 sine of the angle here, 45. Why am I using sine? Because the angle's with the vertical. So for x, the angle's with the vertical. So for x, I'm going to use sine. For y, I used cosine. So T1 sine 45. Anyways, it doesn't make a difference if it's 45. T1 sine 45 is equal to T2. What's T2x going to be equal to? T2 sine 30. Why sine 30? Because again, the angle's with the vertical, so I use sine for x. Let's substitute again. T1 sine 45. We don't know what T1 is, so we're going to keep it as T1 sine 45. It's equal to T2 sine 30. T2 sine 30. What's T2? 20. 20 sine 30. You're going to get 20 sine 30. Which is equal to, if you do it on a calculator, it's 10. Exactly 10. T1 sine 45 is equal to 10. Okay. So this is equation 2. How do I find now the m and T1? Let's see. Let's find an expression for T1. Okay. Over here, I'm going to take everything to the other side. Or you know, I think it's better for me to find an expression for m. Or no, I can't because I don't have m here. I don't have m both here and here. So I'm going to find an expression for T1 because I have T1 both here. It's common. So let me find an expression for T1. If I take everything to the other side, I'm going to get that T1 cosine 45 is equal to, if I take this 20 cosine 30 to the other side, 10m minus 20 cosine 30. Now let me divide by cosine 45. So let me write equation 1. Let me divide by cosine 45 on both sides. I'm going to get that T1 is equal to 10m minus 20 cosine 30 over cosine 45. Let me go down. Try and use as much space as I can. If T1 is equal to this, that means over here, I can substitute T1 with this. So T1 sine 45, I'm going to substitute it as what? 10m minus 20 cosine 30 over cosine 45, sine 45 equals 10. So instead of T1, we're going to replace, I'm going to put this in equation 2. We're going to get 10m minus 20 cosine 30 over cosine 45 times sine 45, right? Because times T1 sine 45 is equal to 10. Let's see. Sine over cosine. What does that mean? Tan, right? So 10m minus 20 cosine 30 times tan 45 is equal to 10. Some people are saying, why are you keeping as 20 cosine 30? Man, because it's you're going to get a long decimal. So I'm going to actually find how much is 20 cosine 30 now. It's going to be equal to 10 radical 3. So I'm just going to keep it as 10 radical 3. So let's see. I get 10m minus 10 radical 3 times tan 45. This tan 45, by the way, it's for all of this, huh? Okay, because it's T1 sine 45. We found T1 to be this. Okay. Sine. Yeah. So you get tan 45. Yeah. Okay. So this 10m, I'm just 10, yeah. Okay. Let me continue. 5. How do I find m? I can divide by tan 45 on both sides. So I'm going to get 10m. I'm going to divide by tan 45 on both sides is equal to 10 over tan 45. Let's do this now. Tan 45, 10 divided by tan 45. You get 10. So you're going to get 10m minus 10 root 3 is equal to 10, right? Okay, is tan 45 1, by the way? Oh, it is, okay. Okay, I didn't know that. And then 10 root 3, 10 root 3, I'm going to take it to the other side. So I'm going to add 10 plus 10 root 3 now. You're going to get, let's keep it like that. So you're going to get 10m is equal to 10, what is it? Wait, 10 plus 10 root 3. So you're going to get m is equal to, let me continue down. So you're going to get m is equal to what? Divide by 10 on both sides. 10 plus 10 root 3 over 10, which should get you 2 point something, I think. 10 plus 10 root 3 over 10. So you get 1. No, you get 2.73. 2.73. T1 sine 10 divided, hold up. 10 divided by sine 45. Oh shit. Oh shit. Oh, I could have just done that. Okay, so m is equal to 2.73 kg. And then to find, okay, wow, I could have just found T1 from the start. Okay, wow, okay, I didn't realize that. Okay, you get m is equal to 2.73 kg, and then you can just substitute T1 here. You could just substitute m, or you can you can just find T1 sine 45 equals 10. I could have just used that and found, okay, yeah, I saw this here. So T1 sine 45, I could have just done T1 sine 45 is equal to 10. So you're going to get T1 is equal to 10 divided by sine 45, which is equal to 14.1 newtons. So you could have skipped all of this. I'm gonna, just gonna re-explain this. So you guys, because I feel bad, you can take this here all if you want. Don't screenshot it. Don't. Let me go back up here. Okay. Okay. My eraser, it's taking its time. It's taking its time. Just give me a sec. Okay. Yeah. So over here, let me erase this as well. Okay. So over here, when I said T1 sine 45 equals 10, I could have skipped all of this solving and just found that T1 is equal to 10 over sine 45. I didn't realize that this is just a normal equation. Okay, 10 over sine 45 is going to be 14.1. So you get 14.1 newtons. Okay, and then T1, you get 14.1. So you go back up here to equation 1 and substitute T as 14.1. So you're going to get 14.1 times cosine 45 plus 20 cosine 30 is equal to 10m. So you just get m is equal to all of this divided by 10. So 14.1 cosine 45 plus 20 cosine 30 over 10. This was equation 1. Okay, so you get this, you get this. Okay, which is m is equal to, let me see, 14.1 cosine 45 plus 20 cosine 30 over 10. So you get, here I got 2.72. 2.7, how much is it supposed to be in the marking scheme? Here I got 2.73. Yeah, 2.73, yeah. 2.73. So m is equal to 2.73 kg. So you get, this is m and this is t. Okay. I forgot. I'm sorry, huh? You could have just solved it in 2 steps. I'm very sorry, guys. Really. Very sorry. You can screenshot this. Okay. Let's see the chat. Can't we do 10 divide sine 45 to get you? Yes. Yes. See, I should read the chat. Don't forget the dinner, little bro. Sandigo. Thank you so much, Sandigo. I already ate dinner. I ate Chinese food. But thank you so much for the donation, Habibi. Thank you. 10 divide sine 45 is correct. I'm very, very sorry, huh? I'm so sorry, guys, for the 55 people that are currently watching me. Oh, it just went down to 53. Okay. Okay. We're done with this one here. Again, I don't know how I didn't realize that. You could have just hit shift solve on that thing. But I decided to take my time solve. Okay, so now I thought I was being smart, wallah guys, but I ended up wasting too much time. So it happens, wallah guys. I might get demonetized if I say that. I might game end myself for that one, guys. Okay, so let me download this. Question 3. Okay. Okay, so these are all pretty much the same concept, yani. I kind of expected this. Okay, so we need 1.6 and 1.2 as our answers. So, 87. No, no, no. Like I got 8. I got 8. 88 was 87 squats. Okay, so 104. So no questions in the chat. Surprisingly, uh, I'm very surprised no one is asking any questions. Since you ate dinner tomorrow, since you ate dinner, don't forget the lunch tomorrow. Well, thank you, Sandigo. Thank you so much. I won't forget. I'll get cafeteria food. Walid, I have a question. Oh, was good. Anna, by the way, do I have the chats? I don't. Oh, I have it off.
Am I drunk?
Mm,
No way.
Sendigo super chatted
I should. I'm so sorry, guys. So sorry for
Since
that one,
you
guys.
ate dinner, don't forget the lunch tomorrow, lil bro.
Okay. So Anna, I'm seeing the viewer count going down constantly. Mechanics can't be that hard, guys. Wallah. Um, Walid, I have a question. Didn't Ghassan call you a failure? Please, it's Mr. Ghassan. That's disrespectful to the head of Department of Physics in the International School of Shoifat in Sharjah. But yes, he did, but he was just joking around, you know? Okay. A particle. A particle P of mass 0.3 kilograms is held in equilibrium above a horizontal plane by a force of magnitude 5 newtons acting vertically upwards. The particle is attached to two strings PA and PB of length 0.9 meters and 1.2 meters respectively. The points A and B lie on the plane and angle APB is equal to 90 degrees. See diagram, find the tension in each of the strings. So this looks like an interesting question. Let me just leave. But let me solve again. I'm gonna start. I'm gonna start by finding angle A and angle B. Okay. Tan of A is gonna. Okay. What's Lami's equation? Okay. Is equal to 1 opposite over adjacent. So A is gonna be equal to shift tan 1.2 divided by 0.9. Mm. Mm. Yeah. Okay. Mm, Okay. 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 3.13 degrees. Okay, so this is 53.13. This is 36.87. Okay, I'm gonna solve like this now. Okay, you know I'm gonna use it with the horizontal now. I won't use it with the vertical. I'll use 53.13 here, and this one here I'll use it as 36.87. Okay, let me draw the FBD. I'll get this. Okay, so you have the force going up it's 5. You have here, you have it's gonna be here. It's called this T1, TA. Here, 36.87. Okay, so TB, you have weight, you have TAX, TB. Hold up. Okay, bro. Okay, you have this here. Okay, let me resolve the forces now. I'm not يا I'm not. Okay, TA. If this doesn't work, I'll try using the Lami's equation. Okay, sigma f x is equal to 0. So TAX, so TA cosine 53.13 is equal to TB cosine 36.87. Okay, then sigma phi is equal to 0. So 5 is equal to the weight 3 plus TA sine. Ah, maybe because it's going to the left. TAX. Okay, okay, okay. Oh, it should be negative. Oh, it should be negative because it's going to the left. I think oh my god. Okay. Yeah, so 3 plus TA. Let me continue. 3 plus TA sine. Oh, shit. What am I doing? Wait, no, it shouldn't be negative. حتى if it's on the left, it shouldn't be negative. Okay, TA sine 53.13 plus TB sine 36.87. Okay, I got this. Stop. Oh, my YouTube crashed. Okay, I got this. 2 is equal to TA sine 53.13 plus TB sine 36.87. Okay, you're gonna get type. Okay, I want to use. I'll find an expression for TA. So it's gonna be TA sine 53.13 equal to 2 minus TB sine 36.87. Okay, divide by sine 15. Okay. Over. Okay, you get this. So then here I'll just substitute. Okay, But there's no way. You're supposed to do it like this is the way the school taught us. 2 minus TB sine 36.87 over sine 3.13 times cosine. Whoa. Whoa. No, no, no. You know what? I should have done it the other way around. Should be sine over cosine up. Okay, okay, okay. I want cosine to be in the denominator, so I'll find TA over here, not over here. So TA is gonna be TB cosine 36.87 over cosine 53.13. Okay, طيب TA over here, I'll substitute it now. TB cosine 36.87 over cosine 3.13 times sine 53.13 is equal to plus TB sine 36.87 is equal to 2 sine over cosine, so it should be, man, I'm telling you there's no way, and I'm doing this wrong. 36.87 times tan sine over cosine 53.13 plus TB sine 36.87 equal to 2. Okay. Okay. Let me actually solve this. You know what? Let me actually try solving this. Okay. So TB. Okay. Let me factor out TB over here to make my life a bit easier. I get cosine 36.87 times tan 53.13 plus sine 36.87 is equal to 2. I just factor out TB because I don't trust my calculator after what I did. Okay, so cosine 36.87 times tan 53.13 plus sine 36.87. Then 2 divided by answer. You get 1.2. Oh my god. We actually got the answer. Shakla, I did the miscalc. TB is equal to 1.2 newtons. And then TA will just be equal to this. Okay, so 1.2 cosine 36.87 over cosine 53.13. So you're gonna get 1.2 cosine 36.87 over cosine 53.13. 1.6. So you get 1.6 newtons. And I forgot the vector symbols. Every time, I think I'm gonna get it wrong in my exam. I forgot vector symbols in every single exam. As every single question we solved. Anyway, this is how you solve it. I don't know why I was lagging in the first time. I think I hope I can cut out the whole part in the recording. I will if I can. You can use Lami's theorem as well if you were taught it, if you know it, if you want to Google it. Apparently, it gets you the same thing. For those who know, you can use Lami's theorem. That's it. I hope, and maybe someone understood. I don't think anybody understood. So if you watch back the recording, just watch back the way I solved the second time. I'm just gonna write over here. Okay, you're gonna get this. Okay, I'll put over here that b is equal to. Okay, you can do this if you want, whatever. I'm gonna write over here. This is equation 1, and this is equation 2. Okay. Well, I'll cut this out of the stream, of the recording. Anyway, thank you for watching, guys. You can use Lami's theorem. Let me see what's Lami's theorem. Where's Lami's theorem? Where's Lami's theorem? What? Over here, يعني. Uh, uh, uh. Yeah, this year. Okay. It's 120 something. Uh, 90, 143.3. Yeah, yeah. Uh-huh, uh-huh. Okay, okay. 90. Okay, 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 okay. Oh, so you solve, yeah, okay. Oh, okay. Okay, apparently that's another theorem you can do called Lami's theorem. I would explain it. I would explain it, but I'm pretty sure most people won't understand because it's like something new they've never seen in their life. Uh, in my opinion, it's way easier than what I just did. I don't know why the school doesn't teach us it, but I think it's because it only applies to one specific case of forces, and that's when you have three direct forces. Uh, but it's because it just applies to this. So I'm gonna end the stream here. I'm gonna cut out all the bullshit out of the stream. Thank you so much for watching. Good luck tomorrow.